Okay, so we are going to learn how to graph rational functions. This is the parent function. What that means by parent function is that it is like the simplest form. Okay, so my vertical asymptote is going to be x equals 0. So my horizontal asymptote is going to be y equals 0. This is only for the parent function, though. I'm going to show you how to do transformations here in a minute. So what that means is that whenever you're graphing, you're going to have two functions. One's going to be on the left and one's going to be on the right, and they're never going to touch the horizontal or vertical asymptote. So your domain is going to be split up, and this is just something that you have to have memorized. But your domain is going to go from negative infinity, and then it's going to stop. It's going to stop at your vertical asymptote. So it's going to stop at 0. And then it's going to start back up again. So we're going to separate it with this U that we call union. And it's going to start back up again, and it's going to go from 0 to positive infinity. And we have all of the open brackets because that means like it never touches 0, but it gets really close. And then it goes from 0, and then it goes back again. So just a good rule to memorize is that it's always going to look like this. It's always going to be split up into two, but it's going to stop at your vertical asymptote. So whatever number is here is going to be your whatever your vertical asymptote is. Can't really write that. Okay, and then your range is going to be the same thing, but it's going to stop at your horizontal asymptote. So think about domain goes with vertical, and range goes with horizontal asymptote, because remember you're doing range from bottom to top. So my range is going to look like the same thing. It's going to be negative infinity. Then it's going to stop at 0, which is my horizontal asymptote, y equals 0. Then separated by a u, which we call union, 0 to positive infinity. So if I were to write rules for domain, it's always going to be all real numbers except your vertical asymptote. So what it will look like, the way that we write it, is negative infinity to vertical asymptote, union, vertical asymptote to positive infinity. And it looks like that every single time. And VA just stands for vertical asymptote, like whatever that is. Then we have the same rules for range. It's going to be all real numbers. That's what the R means, all real numbers, except my horizontal asymptote. So it's going to be negative infinity to horizontal asymptote, so my HA, and then a union, and then HA, horizontal asymptote, to positive infinity. So if you can kind of memorize these, then that'll be helpful. So if I were to graph this without a calculator, I'm just going to plug in x and y values. So I'm just going to make a little chart table over here. And if I were to plug in x equals 1, then I would have y equals 1 over 1, so 1, 1. So I can put a point at 1, 1. If I were to plug in negative 1, I would also get a negative 1. So negative 1, negative 1. If I were to plug in 2, then my y value would be what? 1/2. So 2, 1/2. If I were to plug in negative 2, I would have negative 1/2. So you'll see that it's approaching the horizontal asymptote like this. And then it's also going to approach the vertical asymptote. So you're going to have a graph that is above, like in the top right-hand corner, and you're also going to have a graph that is in the bottom left corner. So when you graph 6 over x, we call that a vertical stretch by a factor of 6. So it's kind of stretched out more. So for transformation, whatever this number is right here, we would say vertical stretch by a factor of 6. So if you look at on your calculator, horizontal and vertical asymptotes, are they still the same from what the original one was? Yes, so we have vertical asymptote is x equals 0. Horizontal asymptote is y equals 0. So I'm going to draw those. Domain would be from negative infinity. It would stop where? 0. Then there's a u. Then 0 to positive infinity. Range, same thing. Negative infinity, 0. Union, 0. Positive infinity. If I were to graph this without a calculator, then I would need to plug in x and y values and then solve. So a couple that would be easy would be x values that are divisible by 6. So what are the factors of 6? We have 1 and 6. We also have negative. We have negative 6, but if I'm just doing positives right now, 2 and 3. So just numbers that are divisible by 6. Like what can I plug in for x that's going to get me like a nice even number instead of a fraction? So 6 over 1 is 6. 6 over 2 is 3. 6 over 3 is 2. And 6 over 6 is 1. So I have 1, 6, 2, 3, 3, 2, and 6, 1. If you do the negative values, so negative 1, negative 2, negative 3, negative 6, you're just going to get a mirror image of the function. So I can put a point at negative 1, negative 6, negative 2, negative 3. It's kind of like it's a reflection or a flip. Negative 3, negative 2, and negative 6, negative 1. I'll specify on the quiz, like on the last test I said 2. So probably 3, but I would always specify. All right, so you're not always going to have horizontal and vertical asymptotes that are equal to 0. So this is the general equation right here. A x minus h plus k. A is my vertical stretch, and whatever letter or whatever number A is would be the factor. So by a factor of 2, by a factor of 3. My vertical asymptote is x equals h. And remember that you flip the sign. So you flip the sign of h. And then my horizontal asymptote is k. You keep the sign of k. For vertical or for transformations, it's always going to go left or right based on whatever my h is. So if whatever my vertical asymptote is going to be whether it's left or right, that many units. So if you had vertical asymptote is x equals 2, then it would go right 2. In this case, we have x plus 2. So my vertical asymptote is at x equals what? Negative 2. So that means that I'm going to go left 2. And then I'm going to put a vertical asymptote at negative 2. Then my k value is what? Negative 1. So my horizontal asymptote is at y equals negative 1. I keep this sign. So I'm going to put a horizontal dashed line at negative 1. And so then my transformation for k is up or down. So it's going to be down 1. And then do I have a horizontal or vertical stretch? or not a vertical stretch, it's always vertical. A vertical stretch by a factor of what? 4. Well, that would mean that it's going to be flipped. So I want you to put it in your calculator. I want you to see what it looks like. So whenever you put it in your calculator, you'll see that the negative sign right here makes it go in the top left quadrant and then the bottom right, whereas just the parent function would be top right and then bottom left. And yeah, if it's a negative, then it'll be top left, bottom right. If it's a positive, it's top right, bottom left. But if you plug in x and y values, you'll be able to see what it looks like. So before I graph it, what would my domain is negative infinity, and then it stops where? -2, union, -2, positive infinity. And then my range is negative infinity, -1, union, -1, positive infinity. So if I plug in x and y values to test, I need numbers that are divisible by 4. So like I want x plus 2 to be divisible by 4. So what is an x value that I could plug in? 2. Okay, so when x equals 2, I have -4 over 4 minus 1. So -1 minus 1 gives me what? -2. So I can go to +2, -2. What's another x value that I could try? Could try 6. 6 is going to have a fraction, so you have -4 over 8, so -1/2 minus 1 gives me -3/2. So it would be about here. And we could test one more. What if we test when x equals 0? That could be a good one. So when x equals 0, I have -4 over 2, which gives me -2, minus 1, so -3. So I have 0, -3, like this. And then I can just connect the dots. Like that. If you wanted to test -2 and -6 and 0, it would just give you, well, and then the -1. So we could test those if you want, or if you just wanted to, you could just kind of connect the dots like that. I'm going to tell you how many points I want you to plug in. I'm not going to be too picky with the ordered pairs with non-calculator graphing. The main things that I would grade would be vertical, horizontal asymptote, domain, range, transformations. The actual graph itself, I'm not going to be super picky about. Just, I'm looking for these things right here. Okay, these are the ones that you'll see like most typically, these types of graphs. Basically, if you have a function on the top and you have a function on the bottom, so that's what the px and the qx represent. Like if you have x plus 5 over x minus 3. Like you have a function on top and a function on bottom. There's different ways to solve for vertical and horizontal asymptote and x-intercept and y-intercept. I would highlight these and put memorize next to it because this is one of the most important things you'll learn this entire chapter. It's like the meat of the chapter. It's just the part that is really, 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 really important. So like the last test, the properties of logarithms was important. This is important. Knowing these 4 things. So highlight it, star it, memorize, write out the rules before you go to sleep. I do not know. So for vertical asymptote, your denominator can never be 0 because anytime you divide by 0, your graph just kind of blows up. That's why we have asymptotes at those numbers, because when you divide by 0, there's an asymptote there. That means that the function can never, ever, ever touch that value. So to solve for your vertical asymptote here, you set the denominator equal to 0. That's kind of the shortcut way to say it. So set denominator equal to 0, and then solve. So if it's a linear function like x plus 3, then that's really easy. But we'll see in the next lesson that we'll have quadratics that we have to solve, but we'll just factor those. So for vertical asymptote, set the denominator equal to 0. So if we look at number 3, the denominator is x minus 3. So for my vertical asymptote, I'm going to say x minus 3 equals 0. So x equals 3. So my vertical asymptote is x equals 3. So I'm going to put a little vertical asymptote at 3. For horizontal asymptote, this one is a little bit different, and it just kind of takes some practice. But basically, you look at the top number and the bottom number, and you look at the degree. So we would look at 2x, and we would look at x. You look at like the leading degrees of top and bottom. If your top degree is bigger, then you have no horizontal asymptote. So for instance, if you had x squared over x, something like that, like the degree on top is bigger than the bottom degree, then you would have no horizontal asymptote. If the degree of the bottom is bigger, then your horizontal asymptote is y equals 0. So that would be like x over x squared, something like that. And then if the degree of the top and the bottom are the same, like we see in number 3, then your horizontal asymptote is just the rational of the leading coefficient. So it's basically just the number that is left over when the x's cancel. So for number 3, my horizontal asymptote, I have 2x over x. The x's will cancel, and that just leaves me with a 2. So my horizontal asymptote would be at y equals 2. So I'm going to put a dashed line here. From that, I can now solve for my domain and range. The same rules apply. So my domain would be from negative infinity, and it would stop at what? 3, then union, 3 to positive infinity. And then my range, same rule, negative infinity, it stops at 2, union, 2 to positive infinity. For x-intercepts, so this is kind of the third thing we solve for, our x-intercepts. With those, you set your numerator equal to 0. So if you want to write that out to the side, set numerator equal to 0, then solve. Those are going to give you your x-intercepts, okay? There could be more than one, depends on the degree of your function. So my numerator is 2x plus 1, so 2x plus 1 equals 0. So x equals what? Negative 1/2. So I would have an ordered pair at negative 1/2, comma 0. Like this. Then the last thing that you solve for is the y-intercept. So last thing is y-intercept, and that's just letting x equal 0 and simplify. So plug in when x equals 0. So when x equals 0, solve for y. So in this case, I would have y equals 0 plus 1 over 0 minus 3, so that gives me negative 1/3. So below here, I think there's a space, but it won't let me scroll. So I would have an ordered pair at 0, negative 1/3, like this. Then if I wanted to plug in any other x values, I could, but I'm just gonna, these are like the main 4 things that I want you to memorize and solve for. And like I said, I'm not going to be too picky with ordered pairs and stuff like that. I just want you to have these 4 things memorized. So then I would connect the dots, and then it's going to be opposite on the other side. So just knowing that they're in opposite quadrants, like diagonal from each other, and then plugging the x-intercept and y-intercept in. All right, so the 4 things that we're solving for, I usually just write these at the top. So we do vertical asymptote, horizontal asymptote, x-intercept, y-intercept. So that gives me enough space to work everything out. For vertical asymptote, we do what to solve for vertical asymptote? We set denominator equal to 0. So negative x minus 1 equals 0. So x equals negative 1. Negative 1. So I'm going to go over here and I'm going to put a vertical asymptote at negative 1. And my horizontal asymptote, what is the rule for that one? What do I do? Yeah, if they're the same degree, so I look at the leading degrees or the leading coefficients and I have negative 3x over negative x. They're the same degree, so I just look at the numbers in front because the x's will cancel. I have negative 3 over negative 1, which just reduces to a positive 3. So my horizontal asymptote would be at y equals positive 3. So I'm going to put a horizontal dashed line at positive 3. X-intercepts, how do I solve for x-intercepts? I do what? Set the numerator equal to 0. So negative 3x plus 2 equals 0. Negative 3x equals negative 2. So x equals 2/3. So my ordered pair would be at 2/3, 0. And then my last thing that I solve for is y-intercept. So I plug x equals 0. So when x equals 0, what is y? So I have y equals 0 plus 2 over 0 minus 1. So that gives me negative 2. So the ordered pair would be 0, negative 2. So I'm going to plot those values. So 0, negative 2, and 2/3, 0. Then I can connect the dots. Yeah, I'm not going to be too picky about the graph, to be honest. I'm going to be grading mostly these things and then looking to see that you have them in the right places. So my domain, last thing, my domain would be negative infinity. It stops where? At negative 1 at my vertical asymptote. Union, negative 1, positive infinity. Then my range is from negative infinity. It stops where? It stops at 3. Union 3 to positive infinity.